Hello, everyone. Welcome as we get everyone in here. I'll let everyone get in.
Hello.
Um, my name is Jolene Johnson. I am one of the co-leaders of the Physics of Living System Teacher Network. I just want to welcome you and thank you so much for spending your Saturday with us learning about physics. And I also want to say thank you um, to Chris Orban, who's going to give a great talk. And then we also have Paul Bianca, who's going to be running the meeting. Just a quick update for anyone who's wondering. I don't know if you heard, we are part of Harvard, so we lost our funding. We are working on it. We have some bridge funding, and we are definitely going to be back in the fall, some one way or another with more talks. So just wanted to let you know that we are working on it and hoping to find funding. Otherwise, welcome. Thank you guys for being here, and I'll hand it over to Paul.
Okay, thank you, Jolene. My name is Paul Bianchi. I'm a physics teacher at Horace Greeley High School in Chapel, New York. And it's my pleasure to introduce Dr. Chris Orban, who's an associate professor of physics at Ohio State, who specializes in computational physics, astrophysical plasma, large-scale structure of the universe, and fortunately for us, physics education. And he's going to speak today about his STEMcoding project, which exists to reimagine introductory STEM courses with computer science in mind. So with that, I'll hand it over to Chris. And if you want to put questions in the chat when Chris pauses for a breath, every now and again, I'll throw them over to him. Okay, so thank you, Chris.
Yeah, thanks so much. I'm gonna go ahead and share my screen, and then I'm actually gonna turn my camera off so you can just see my screen here. So hopefully that'll work. It's great to be here. It's great to be able to tell my mom that I'm presenting at Harvard. So um, that's a special pleasure. And let's see. All right, let me go ahead and do this full screen like that. Can people see me? Sarah, can you give me a thumbs up? Okay, great. And then I think I can do that. And then I think I can hide the video panel. Hide floating meeting control. There we go. Perfect. I think it's working. Okay.
And you
Um,
need to remove those.
all
And
right,
I'm
let's
in
do this.
there.
Right.
So, hey, Celestine.
Hi.
Um, the so hopefully people can see me. When the pandemic hit, the first thing I did was put a green screen in
I agree.
my home office. So some of the best computer science teachers. So Miss Frizzle from the Magic School Bus teaches computer science skills in one of her
Yeah, I
episodes.
just
And
came on.
so
I don't know. They're probably just
this is
like figuring
something
it
that
out.
some of you have already considered to do, and I'm going to give you sort of my take on the best way to do it without losing your mind, because it's very hard to do. Uh, there's so many different pressures on the curriculum of we want you to do this, we want you to do that. We're going to put this in AP this year. It wasn't last year. So I'm going to give you my best ideas for how to do that. So um, I wear a lot of different hats. Uh, so I do education research. I also do plasma physics research. The STEM coding project is a couple of people. So most of us are from Ohio State, but there's also Julie Butler from Mount Union, who graduated from Michigan State in nuclear theory. She teaches data science at University of Mount Union, which is a kind of a small college in Ohio. But we'd love to have more collaborators on this project, and that's part of why I'm excited to be here. So also Zimmerman on math, so physics, math, we're all kind of all over the place. So I couldn't quite fit the title, How to Integrate Computer Science and Data Science into High School Physics Without Losing Your Mind into this, into the banner here. But that's basically the idea. If you're going to do it without losing your mind, you're going to need these five different features, these five different things. And so that's what we're going to kind of go through. So this is kind of an outline of my talk that you'll see. Um, and so the first thing that you're going to need, and by the way, computer science and data. So my view is that computer science is overall very similar to data science. And I'll get into exactly what the delineation is. My view is also that physicists have been doing data science from before it was cool. So there are people that say that the first data scientist was Johannes Kepler. And I kind of agree with that point of view. um, in the way that Kepler approached the models of the day and improved upon them is kind of that idea. So anyway, data science is the new thing, but it's also the old thing that physicists have been doing for a long time. All right. So the first thing you're going to need if you're going to integrate computer science into a science course like physics is you're going to need activities, the short activities designed by actual science and physics teachers, right? Because when you go out into the computer science world, you're going to see a lot of things that are designed by computer scientists for what they think would go into a physics course or a science course. But what you really need is someone who actually teaches physics to who also knows the computer science to design that. Because I'm not here to teach computer science for the sake of computer science. Like there's other people, that's their goal, that's fine. My goal is to teach computer science as a tool for solving science problems, as a tool for solving math problems. That's what I'm here to do. And so we have all sorts of, this is not even the full list. Like we have something like 30 different activities. But the way that we started almost 10 years ago is we started by releasing activities on ourcode.com. So this is the world's most popular computer science education website, ourcode.com. And so we sort of started releasing these things year after year. And so one way of telling the story of the STEMcoding project from when we started is this. Now, an important way of explaining our approach, right? Anyone can design a Pong game. And in fact, if you go to ourcode.com or just search, you'll find different people making Pong games. So for example, on the Swift playgrounds, there's a Pong game there. And if you look at that Pong game, the goal of that Pong game is to teach you object-oriented programming. And in fact, all of the physics of the bouncing of the ball is hidden within a library. So that Pong game teaches you absolutely nothing about the physics, whereas my Pong game, it's all about the physics, and it's nothing about teaching computer science for the sake of computer science. There's no object-oriented stuff in there. But the point is that the kinetic energy of the ball is the same before it hits the top as it is after. And one of the things in the next generation science standards is energy conservation, right? And so you can do one activity that does computer science and energy conservation all in one fell swoop, and it's game-like. And so you end up with this game that you can actually play. So a lot of the things that you'll find that, so if you're of the mind, okay, well, here's what I'm going to do. I'm going to take the college level coding stuff, I'm going to put that into a high school class. A lot of times the college level coding stuff is not so much a game that you play, that your students co-create, as it is, here's a thing that we can write the code, press play, and watch what happens. So that's not what I'm about. I'm about, let's make an interactive thing with this that has the physics that we're interested in, right? So when you think of interactive, simple games with good physics in them, you think of the asteroids game. We have an asteroids game. You think of the lunar lander game. We're trying to land on the moon without crashing the ship. So we have those games. And what's interesting about the lunar lander game is that it's not just that we get this game working. It's not just that, all right, we finally have all of the lines of code there. It's also that you're double checking that the result of that code to make sure that it matches up with what the equations say that it should take to the free fall time to land, to hit the moon if you're not firing the rockets at all, right? Because in addition to the emphasis on interactive stuff and games and putting the physics into the game and all that sort of thing, the other main thing that we're trying to communicate is that a complex simulation is never correct because of its complexity, right? It's only correct if we test it to make sure that it's correct, and that's what we're doing here. Is we're calculating how many seconds it should take for that rocket to just crash and burn if you don't fire the thrusters, and then we're double checking the simulation to make sure that happens. So that's a big part of our approach. Now in 2019, like a moth to a flame, I was fascinated by the black hole image like everyone else was. And so in 2019, our hour of code activity focused on black holes. And so I don't know if you remember this image from 2019. This is Katie Bowman. She's a Caltech computer scientist, and she's looking at one of the first reconstructed images of hot gas falling into a black hole in a galaxy. So this is her with all of her hard drives. It has all the information on it. And my message is basically that it's important to take advantage of that moment, that image that everyone saw, because this project shows you everything you need to know about how modern physics research works, right? So modern physics research isn't all like blackboards. It isn't all string theory trying to drive all these things. It's physicists and astrophysicists working with computer scientists, working with statisticians, working with radio engineers, everyone working together. And like the miracle of this image uh, is that they were able to come up with algorithms that could stitch the data together from all these different telescopes. So that is how physics research actually works. A lot of the times that's not really what our physics classrooms look like, and so that's part of my motivation for doing all these things. So you can find those activities there. You can see that we're double checking. We're doing things like calculating the escape velocity, which is something that could fit well in a high school physics course. Another related activity to that, released after that, is that um, if you've seen the Hidden Figures movie that talks about Katherine Johnson's work at NASA in the way that she did many different things, but she helped to calculate and double check John Glenn's trajectory on the Project Mercury, which in Ohio is a big deal because John Glenn's from Ohio. But a lot of people celebrate the work that she did, but not a lot of people are creating activities that kind of get into the kind of science and math that she would have known and used in order to do those calculations. And specifically what she was doing is that there was a new computer. Computers were new at the time, right? So her job was to double check the prediction of that computer using pure math to try to see if there's a bug in the code. And in this activity, you kind of launch this thing and it kind of goes and you can see what the simulation shows, and then you can compare that to the math of, for example, how fast should it be going if it's going to do like a pure circular orbit, that sort of thing, which of course is something Katherine Johnson would have known. So this is my effort to uh, to give some good scientific meat to these discussions. This is my friend Jamore Givens, who's in New York City somewhere doing astrophysics, but he graduated from Ohio State. We do have electromagnetism activities. I know there is some electromagnetism content on the NGSS. So if we have time, you can ask me about that and we can get into more of that. But so you need NGSS aligned activities. You also kind of need some sort of framework that meshes well with the NGSS. And the good news about that is the NGSS talks about mathematical and computational thinking as essential science and engineering practices. And so the NGSS back in 2013 was very forward thinking in the way that they anticipated that computational thinking would become part of physics. I think they're even more forward thinking than we actually have managed to get there. But this article that I wrote in 2019, which is in the Physics Teacher magazine, kind of goes into the philosophy of how we do this, goes into philosophy of how computer science is a tool, like I've kind of already said. So please check that out when you get a chance. This is an alignment guide to all the different activities that we have, almost all the activities that we have. So I'm trying to get in the nitty-gritty of what exactly do we line up with and why. Paul, is there any questions at this point?
Yes, I was just going to jump in, Chris. We have a question from Celestina Pangan. I'm sorry, I don't have my glasses on. With the emergence of AI, how much value is there in learning coding in STEM courses in K-12 classrooms? So the effect of AI, does it change the value?
Mm-hmm. Yeah. So I have many different things of saying about that. I mean, I certainly don't think AI makes it any less important to learn coding. I think I think the opposite is true. So the way that I'm thinking about AI now is that in computer science now is that the AI models allow you to have like kind of expert coding help anytime you need it. And so the thing that we're moving towards is a world where um, if you're running a small business and you think to yourself, we really need an app for this, like a custom design app that does exactly what I want it to do, or we really need this website. And, a year ago, it would cost $75,000 to get a programmer to design that website for you or that app. And then you would have to pay them over $10,000 a year to maintain it. But the AI models allow you to, I don't know if people have heard of vibe coding. So the AI models allow you to, not hire a $75,000 software developer. And it should allow small business people, if they're intrepid enough to try it, to take advantage of those sophisticated models. It's just that you have to have the courage to try it. You have to kind of have the courage to say, like, this would really benefit our business uh, if it existed. And when you're teaching computer science in any class, in any high school or middle school, elementary school class, you're giving people the courage to try it because you have to have at least some knowledge of what the AI would be doing and the rules that it's trying to follow in order to guide it. That's one advice that I have. The other comment is that, um, and so I'm a professor and I'm prone to ranting and all these things, right? So I confess. My number one rant is that there are a lot of people out there who think that the main goal of computer science education is to make sure that every kid has a computer science class that they can take. Um, those people have not grappled with the reality that only 1 in 5 students, high school students in America, on average, actually manages to take a computer science course. And so if you want to be on the train of saying, let's get it from 1 to 5 to 5 out of 5, that's fine. I'm on the train where every student has a math teacher, every student has a science teacher. If you're serious, if you're genuinely serious of putting computer science into the toolkit of students, then you will spend almost all your time trying to figure out how to put computer science into math and science classes and how to grease those wheels. But you can ride that other train and you can wait for decades until we get 5 out of 5 students getting a computer science class. But I know which train that I'm on, and I encourage you to walk along with me in that train. Cool. So I'll pause again for questions in a few more minutes. So the other thing you're going to need to avoid losing your mind is actually videos of these activities. So like I can train you over the summer to do this and that, but it's very helpful to actually have a video of like what exactly did we do 2 years ago on June 3rd to in this tricky step of this activity. And so we've worked very hard on, I don't know if you guys can hear the audio there. But we worked hard to make videos on our YouTube channel. Yeah, so that's our YouTube channel. So we have lots and lots of videos there. Um, we've we worked hard to make sure all kinds of different people appear on the YouTube channel, so it's not just me. There's plenty of folks from Ohio State, University of Mount Union, um, and so it's something we're very proud of. So yeah, look, there's a subscribe button. So check that out. The other thing that you're going to need is, I mean, the YouTube channel, it's partly about the students, but it's also about the teachers. So it's secretly it's all about trying to make sure the teachers know what to do, so they can go back and see how we did it. But the other thing you're going to need besides videos is, and this came to a head during the pandemic, where people couldn't be in the classroom. You can't be looking over the shoulder of the students. It was already kind of difficult to grade these things because it involved looking over all the lines of code and making sure the programs are running. So during the pandemic, we got creative and figured out ways to kind of automatically check to see if the students had completed the coding tasks correctly. And so we can give them green checks if they get it right. If they make a mistake, we'll give them a red X. And that'll give them some idea of what the problem is, or at least that gives the teacher some idea of how far they've gotten. So initially, before the pandemic, we just had nothing on the sort. We just had to look at this thing. And so that's been a big improvement. So for example, here, this is our lunar lander kind of game. And you can see that if you can land the ship, you get a little green check here. But you notice we've not yet added a timer to the simulation to see how many seconds have elapsed. And so we don't yet have a green check here. So a lot of our activities have these, what I call milestones. And this is so important for just keeping everybody on the same page. It takes so much work out of the teacher to be able to do that. We use a framework called P5JS, which is a JavaScript-based framework. There's not a lot. I mean, I constantly get the question of why aren't we using Python, which is fine. Python is pretty common in physics and other parts. I mean, JavaScript is also in the top 3 languages that people use. The reason I like it, it looks a lot like C or C++ or Java, so which are all languages that physicists use. But because of the amazingness of P5JS, which is very popular in computer science education, we could it wasn't too hard to put those things in there. So I'm happy to answer more questions about exactly how we pulled that off. All right. So the other thing is training. So so we are going to be at the AAPT summer meeting in Washington, D.C. So there's a workshop, I think, scheduled for Sunday, August 3rd with that. So you can look out for that workshop. So it's an in-person workshop. If you want to do something virtual, um, we've we've uh, we've waited a while to discuss exactly what we're going to do for the summer because it's been a challenging semester, let's say. Anybody else know what I'm talking about? Harvard? Anybody? Okay. Challenging semester. Um, we haven't lost any funding, but uh, it's been hard on everybody. So what we can do this summer is we can do a couple of days of virtual PD. And if you want to do that, so I'll let you maybe take a screenshot of that real quick, and I'll provide the PDF to PoLS-T folks. But we need to decide whether we're gonna what kind of activities we're gonna focus on: astronomy stuff, E&M, physics, intro, advanced. But this is the week that we're gonna try to do. So you can check that out. Normally we do a summer thing with AAPT that's sort of well advertised and that sort of thing. So this summer we're just gonna do it ourselves. But the other thing one needs is you need classroom management tools to avoid losing your mind. So we developed this site, and which Celestina uses, she likes it. And the idea of this site, there's multiple different sites that you can use to complete these different activities. This one is run by this nonprofit that some professor friends and I started, and so it's not officially connected to Ohio State University, but that's a good thing because it means that we don't need to sign all these forms and things for students to be able to use it. So in a minute, I'll show you how to access this thing if you want. There's also another link that I'm going to show you where you don't have to sign up for stuff to be able to use it. But the point is that this site allows you to assign students different activities, and then students submit their codes and their responses to questions to you, and then you can very quickly look at those responses and give feedback on it and tell them if they need to improve anything or tell them if they did okay. The grading is just a monster. I don't know if there's probably people in the room that have done something like computer science and high school physics, and trying to keep track of all the submissions is among the most difficult parts, and this is our best attempt to try to streamline that process. All right. Why don't I pause for questions again? Paul, is there questions?
Nope. Everyone's enraptured.
Great. Okay, so the big new initiative that we're doing is data science. So I kind of alluded to this earlier. And so when I say that we're doing data science, like we're still physicists, we're still creating stuff for the physics classroom, and the next slide is going to be like, the most data science thing we could think of for high school physics. But we're also thinking about outside of physics, and basically there are different efforts to create a year-long data science curriculum. So there's different colleges that have their own curriculum. So Stanford has a curriculum. Brown University has Bootstrap. There's UCLA has their own data science curriculum, and we have our own data science curriculum. Ours isn't quite as finished as the other ones are, but ours is special because it's being designed by physicists. And math, and my friends in math, and so we're trying to connect it to the physical sciences as much as we can. So I have friends. This is no criticism. So I have friends who teach high school math classes. They teach a data science course. at some point in the course, they analyze what people ate for lunch, right? That's great. But they could also analyze science data sets, and science literacy is a goal of the education system last time I checked as well. And so this is our attempt to do that. And so what we're going to do, which is unlike, I mean, there's other people that are doing Google Sheets, and that's great, but there is no high school data science year-long curriculum that is aligned to the industry credential for Excel. So there's an industry test you can do. So you can put on your resume that I can do Excel. And that test is not wildly difficult. There's actually two tests. There's an introductory test, which is what we're doing. There's also a more difficult industry test. The test for Excel is not that bad. It's basically, do you know how to use all the features of Excel, right? And so we're aligning it so you could do that if you wanted to. So what I'm saying to the people in the room is that if your principal is saying, well, wouldn't it be great if instead of teaching physics, you taught data science? Well, if that's the situation you're into, this is going to be this is going to be the most natural thing for you to try to do. Anyway, so a thing that we developed is the STEMcoding object tracker. This was definitely a project out of the pandemic, right? Because we were trying to figure out how to do these labs at home. And the basic idea of it is that there's different tracking programs out there. We're not the first person to do tracking programs. There's other great stuff. You know, Vernier has a thing to track. Some of the programs don't track. Some of the programs you just sort of click on the object. Some of the programs are really sophisticated. So, for example, there's the tracker video thing. So there's a really sophisticated one that uses machine learning to find the picture, stuff like that. Ours is dumb by design. The way that ours works is that you tell it a color for the object and a color for the background. And if you're careful to design the experiment such you have a solid color background on the back, which doesn't matter what color it is as long as it's different than the object, then this thing just picks it up just fine. And you can do fun stuff like this. So here's some data from what we had. So you get pretty close to 9.8. You know, it's not perfect, but you can kind of do it that way. And so we have a whole article about this that's also published in the Physics Teacher magazine. I don't know if you can tell, I'm a big fan of the Physics Teacher magazine, so make sure to get your subscription. And so we go into how we pulled this off, and there's actually two different modes. Anyway, there's some fun stuff in there to check out. So so we need to get more videos for this, but the code is free. It works in the browser, and so it'll work on a Chromebook. You can upload your own videos to it, and it should work. It's maybe not as streamlined as Vernier video, but it's there, and if you want to improve it, you can go ahead and do that. So
Chris,
all the different, yeah, go ahead.
Can I just jump in? So just rookie question, definition of data science, what is it?
Yeah, definition of data science. So let me reinterpret that question of what's the difference between data science and statistics, all right? Because statistics has been around. I took statistics when I was in high school. Whoops, can you guys still hear me? Paul, can you say yes? Can you hear me?
Yep, audio's okay.
So if you look at the way that a high school statistics course is set up, the way that it tends to go is that because you're trying to hit all the different things in a college statistics class, you know, it tends to go from distribution to distribution. So this is a Gaussian distribution. This is a chi-square distribution. This is a t-test. This is an f-test. This is a linear regression. So it tends to go from, you know, situations in which there's some distribution that there's theoretical reasons to know that it should be that, like the classic example, I guess, is counting the M&Ms in a bag of M&Ms, right? I remember doing that when I was in high school. So there's some like reasons to think that distribution should follow a particular thing. In data science, and this I think is true of, and I'm talking like broadly in data science as an industry, the attitude is that we don't really know what the distribution is. We're not going to sit here and pretend like it's Poisson for sure, like we would in a high school class where we need to cover Poisson statistics, and so we're just going to run with that. So data science is more agnostic about what kind of distributions that we're that we're doing. And so when you're doing data science, you're kind of trying to inch them towards that goal. So I'm calling it data science. Maybe it's introduction to data science. There's people that talk meaningfully of doing data science at elementary and middle school levels. For me, I think once you get to elementary and middle school, what you're really doing is data literacy. But that's the basic framework that I'm working under. So I'm friends with people with the data science for everyone at University of Chicago, that sort of thing. It's data science. Yeah, so I could go on and on, but that's my short version of it. Yeah, and this is a link that has a lot of this stuff. So this is the part where you don't have to sign up for anything. So and none of your student data would be involved. So if you just wanted to use that. So the YouTube channel connects to here as well. I guess the other thing about data science that I'll say is that data science reminds me a lot of computational science. So computational science is the idea that, which is where a lot of my training comes from, where you have some experiment, you run some simulation of it, you try to see what the difference between the experiment and the simulation is, and you try to learn something from that. Maybe you learn new physics. Maybe you're double checking your codes. Maybe you're using your codes to predict some situation that you can't do an experiment on. And so there's this this synergy between computer science and theoretical physics and statistics and computational science, not computer science, but computational science. And I see a lot of that in what people call data science. So people call data science, they call it the data cycle. They say you collect data, you analyze the data, you ask questions of the data, then you collect more data. Those two things seem almost indistinguishable to me. So for a computational scientist like me, I'm all aboard with data science because that sounds almost like exactly what I've been trained to do. Places like Michigan State have entire departments of computational science, which I think is great. All right, so for hands-on stuff, if you want to do some hands-on stuff, and Paul can tell me um, how we want to do this exactly, because I think we will go to Q&A. But there's an activity that I created that is inspired by this game from a while ago. And so if you want to log on to here and try it out, you can do that. You can also just click this link and try it out there as well. And I think I'll go ahead and pause there. Maybe we do some Q&A. And so I can do Q&A, and if people want to try these things out, they can try it out. Maybe they have more questions for me.
There is one question out there now, sure. Chris. Have you developed tiered coding activities to support students with IEPs or accommodations, particularly in schools where computer science is not a dedicated course or available option?
I would love to be more connected to IEP folks. I mean, even with the advanced students, right? So even with the gifted students, what are you going to give them that still aligns with all the traditional learning activities, but actually challenges them? Well, I think this sort of thing would do great. What I don't actually understand, like, and I have a legitimate question to understand is like, how do you get on the radar of the people that write the IEPs? Because the IEPs don't say, hey, you should really use Chris Orban's YouTube channel all the time. Like, that's not what an IEP is written for. That's what I wish it would say, because then I could try to get people to write that in there. But so if people have advice for how I would connect with the IEP world, I would love for that. Because I have heard stories anecdotally of saying, I teach this physics class, and Celestine is watching, maybe she can confirm this. I teach this physics class. There's a student who they don't really like doing labs, they don't really like doing these theoretical worksheets, but they love doing this because they're making a video game, and they can iterate and they can fail and fail and fail and fail and fail and fail and fail until they get it right. So I anecdotally I hear people saying, like, there's a student in my class that has ADHD. They love this. They can't get enough of it. Like, I'm almost to the point where, like, there's an ADHD school in Columbus, and I'm like, I'd be curious to do a research study with them to see if any of this turns out to be true rigorously. Other comments?
Sharon asks, how do your activities and progression compare to modeling physics with coding materials? I know they use Bootstrap, but nothing beyond that.
Yeah, so there's some similarities. So the way that mine works is so in terms of the progression, so this is the move the blob game that I just encourage people to click on. And the basic idea is that you know, you get in there, you have this little circle that moves to the right. If you try to move it to the left, it won't let you. Try to move it up or down, it doesn't work. And then you can the reason it doesn't move to the left is because if you look closely at the code, if you press the left arrow, it says do nothing. That's probably why it does nothing, right? And so this is the first activity you start with, and then you get it to go on 2 dimensions, and then the next activity, the arrow keys control the accelerations, and so the next activity is accelerate the blob, and you control the accelerations. If you look at the way that Bootstrap folks set it up, they spend a lot of time. They spend a lot of their time defining functions. So if you look at the way that the Bootstrap physics activities are written, so instead of doing this update location here, which is basically, you know, the velocity. So dt is the time, that's short for delta t. So velocity times time is the change in position. So you take the x and you add to it the change in position. So the Bootstrap people hate this with a passion, because they have a particular philosophy of what computer science is supposed to look like. And so what they would do instead is they would do something like, they would do like update. So first they would have the students define a function down here. They would say define update x, and then they would do x comma v comma dt. So they would have a students create this function, turn something like that. So they'd have the students create a function, and then they would use this function in the code in order to advance the position, in order to move the position of the thing. And the x, they do the same thing for the y. The reason that they do that is because Bootstrap physics was designed by math people, which is fine. But the math people, the thing that they're excited about is that a computer code gives you an opportunity to define functions, and defining and understanding functions is a big part of like Algebra 1 and Algebra 2 in the schools, and that's where a lot of the students are shaky on that. And so they love it that a computer code can allow you to define a function and help students to understand how functions work. And a lot of their activities is based around that. There's other things that are similar. So like my Apollo moon landing game is very similar to their Apollo moon landing game. So there's similarities. They do have things moving in a straight line, which is fine. But there's this emphasis on these functions. But for me, I just feel like these are unnecessary. And the reason that they don't like what I'm doing is because they don't like things like they don't like this sort of thing is because they don't like the plus equals, because it's not an equal sign. It's not a plus sign. It's something. So this function, so that code element is equivalent to this. So I could have written this code like that. And so, for example, I can run this code. Oh, it doesn't like. Get rid of that. So I can run this code with like that. It works just fine. So I'm taking the value of x, I'm adding it to it, the velocity times the time step, and then I'm saving that to x. The Bootstrap people, they hate this, because if you treat this equal sign seriously, like they would in a math course, it seems to imply that x equals all this, which means that like 0 equals something non-zero. They hate it. They hate it, hate it, hate it. I don't mind it, because every single computational physics code that I've looked at looks something like this. And I try to work very hard just to explain, like, this is not a math world. thing. This is a computer world thing. Like even saw that on the YouTube clip that I showed. Like there is a whole panel of like computer world, math world, and how they're totally different. And so so in my activities, you don't define a function until you're like almost until the 7th or 8th or 11th or 12th activity. It's whereas in the bootstrap physics people, they're defining functions as often as they possibly can because they have different goals. Their goal is to try to get people to do coding in physics, but also be able to pass this Algebra 2 screener thing. My goal is not necessarily the Algebra 2 screener thing, just to be able to do something that makes sense in physics that helps them to solve physics problems.
Peter, we have another question, Chris.
Sure.
Peter says, I'm looking for suggestions for how to instruct students on prompts to ask AI for coding help without having AI return fully coded solutions, especially not ones using library packages, which they want to understand.
Yeah, I mean, the AI models are, as they probably know, I mean, you can ask the AI models like, hey, can you code up the Navier-Stokes equation for me? Like, there's all these amazing things that it can do. I think that if you're going to do that in practice, what you'd have to do is you'd have to create some custom website. So you'd have to create some custom thing. Maybe this is a business pitch that I'm starting right now in the middle of a Zoom call. You create some custom website that connects to OpenAI's model. But then every student prompt that website has, you add a prompt to it saying, don't give them the entire code. So that is what that would probably look like. I think a good question is, what in the world is the Khan Academy doing about this? Because I'm sure they've thought about that problem. I tend not to encourage people to use AI with my stuff because, my stuff is if you ask the AI, if you give the AI the prompts, it's going to give some completely different thing than what I have, and these check marks are going to show up and that sort of thing. Or does that answer the question satisfactorily? By the way, everyone should know that GitHub Education, you can get free access to all the best AI models. So you know how like ChatGPT cuts you off after a certain point with coding? If you sign up for GitHub for Education, nobody pays me to say that, but that gives you unlimited access to whatever the latest ChatGPT model is.
We have another question. Jolene asked, do you have any recommendations for books, apps, or other resources for middle or high school math science teachers who are interested in adding this but have no programming background?
Is math teachers in particular?
Said math or science teachers.
Math or science? Books. Well, so there's math stuff that we've created. So math coding. So I don't know if you can. So these are some of the math activities that we've made. A fun fact about me is that there's a whole nother project that I was involved in called discrete math. So discrete math is a high school course in California and Ohio and maybe one or two other places, Virginia. And it's a fun, it's a course that's sort of taking the place of Algebra 2. And because a lot of people hate Algebra 2. Not me, I'm fine with it, but other people are not as big fans. And so it's an interesting take because it's all about, there's not as much emphasis, there's a little bit of emphasis on polynomials, but it's all about these graphical problems and game theory and network theory and all these fun things. So if you're a person that's interested, so in Ohio, the discrete math curriculum that we created uses a lot of San Diego State's discrete math stuff. So the discrete math project out of San Diego State, discrete math project, Diego State. Yeah. Now, they don't necessarily have computer sciencey stuff with it, but we did develop computer sciencey stuff to go with their curriculum in Ohio, so you can reach out to me about that, and I can try to share with you what I'm allowed to share. Um, in terms of textbooks, I don't know. My kind of feeling is textbooks are kind of dead at this point. If you asked me to write a textbook, I think I would refuse because I would basically say that this YouTube channel is the textbook, is what I would say.
I think, Chris, I think the sense of the question was more for teachers who have no programming experience
Oh, okay.
and are a little intimidated by jumping in here and just
I
wanted a
see.
little background for themselves before they took the kids there. Or do you have any recommendations for things like that?
Yeah. So I love the Lightbot activity. I really love Lightbot. So this is one of the first activities. Code. Um, so I so you can still get this on the Android and iOS. It's one of these things where you give the robot directions and they jump around, that sort of thing. So if you can get all the way through Lightbot, then like they get into some pretty advanced stuff. We get these like subroutines and things. So I love Lightbot. Um, another thing to check out that I think is worth checking out. YouTube shift 5JS. So for the JavaScript framework that I'm a fan of, sorry, there's ads here. The JavaScript framework that I'm a fan of, there's a guy named Dan Schiffman who's a NYU professor, and he just has video after video after video of how this coding framework is working, and gets into the weeds even more than I do. So what I try to do is I try to make sure that you don't have to spend weeks understanding what P5JS can do. I just sort of try to keep it as simple as I can. But if you really want to, but a lot of teachers are of the mind that like, oh, I've got to know this from the ground up. Well, if you want to know it from the ground up, my advice is go to the coding train. P5JS is a good place to start. Yeah, sorry. If I think of another thing, I'll try to let you know. Other questions? Did anybody get the move the blob to go in all the directions? I can't see the chat, so you have to tell me.
Another one just came up in a similar vein. Have given a lot of websites today. Where should I start?
Yeah. So the framework that I like is P5JS, and the cool part about it is that when you go through the references, each one of these has a little code that you can run, and so you can make this little circle here, and then you can move the position of the circle if you want, and go ahead and press run. And I guess I moved it too far, but so you can just sort of mess around with things and get that to work. And then for the full editor, so this is the full P5JS editor that we've been using. So what you could do is go to p5js.org, just kind of see what's there, check out the coding train, open up this web editor, that thing. There are P5JS training things if you want to get into it like that.
I would second you on that because I used to teach kids processing, and
Yep.
then Frank Muscasi pointed P5JS out to me, and I used the coding train with kids, and it's really well done. It's a nice introduction.
Yeah. I have so much respect for Dan Schiffman, for sure. So I mean, I think there's a question like, do you jump into the block-based coding or do you jump into text-based coding? I think the block-based, the Lightbot is what I like, but text-based is this sort of thing. This website, by the way, is run by some sort of nonprofit that's connected to Dan Schiffman and P5JS. So students can create accounts here that would be, so where does the data go? The data is run by a nonprofit there. I've never gotten an email from these people asking for money or like this is all 100% free. It's free essentially because it's being paid for by the New York City's public school system. So it's free for everyone because of that. So feel free to take advantage of it. I know some people have to tell their schools like who owns the data and all this thing, but so this one is the Processing Foundation, which has a lot of people in New York. My thing is run by my nonprofit. We are part of this data privacy consortium thing to make it easier to deal with the data privacy regulations.
So we have a question. As a teacher, how do I tell that a student wrote their own code as opposed to AI or borrowing code posted elsewhere online?
Yeah, so in principle, we could check to see if in the class, if the students have all submitted the same code, we could check to see if all the codes are if 2 or 3 of them are the same, and then like catch them cheating. I'm not a big fan of that approach just because a lot of the times most students are going to derive upon the same code, at least the way they're designed. I mean, I design the activities, you could do it a couple different ways, but usually students do it this way or that way. And so I don't know that you want to try to catch them and penalize them for sort of doing it the way that you were hoping that they would do it. The way that's easier to catch them is the way I do my activities, there's these reflection questions. So if you're on the STEMcoding Heroic Lab thing, there's a tab that says questions.js. And so they ask questions about, is the trajectory curvy? Is it smooth? Is it sharp? And when they answer those questions, if they're answering those questions with like exactly the same words as some other student that you're reading, then you get into cases where it's like, all right, well, clearly you're just sort of copying. But I do encourage my students to work together in groups because part of the way you can pull this off is if there's one student and a group of 4 that's a little bit better at coding than the other ones, they can help bring up the other 3. So and usually with the AI coding stuff, the AI usually doesn't give them very good advice to finish the activities. This has been my experience.
Chris, suppose I'm all in, I want to sign up. Could you walk us through how would you set up a class on STEM coding?
Yeah. So what I can do is if people have logged in and entered that course, what I'll do after this meeting is I'll give you the teacher access for that, so that you can set up a course. I can't like this snap my fingers and all of a sudden allow people to do that, but I can after this meeting I can do it. So the way that you would do it would be so you would let's see. And Paul, if you could put my email in the chat so people can email me after this, I'd appreciate that. Let me go ahead and all right, so I'm going to go in with my teacher account. And And I already have a whole bunch of courses here. So once your teacher account is activated, this teacher tab opens up. And there's 2 different options for creating a course. You can create a course and choose from a long list of activities, or you can start with a template. Probably you want to start with a template, I would say. And so if you teach something closer to physical science, you can click this one. If you teach, I should just have a regular physics. Yeah. So my college course that I teach, which is similar to the AP level, I would click this one. I would click Classical Mechanics Template Course, and then I would click Clone this course. I give it a title, Harvard Course Test. I give it a title, and now I've created a course, and then my students I would give my students this key to join. And so right now the key is kind of complicated, but I can change that to uh, Harvard made. So now I've changed the key to something more memorable. I've updated the course, and so now when my students log in, then if they put this if they put this into their join key, so for example, they like you all did, then they can join this course. Now, you can change this order around, that sort of a thing. Um, you can also add and subtract. So maybe you feel like, you know what, I don't think we have enough time for bellicose birds. So what you can do is you can go in and you can say, you know, I don't think we're going to have time for that. I'm going to unclick that. But I'm excited about data science. I'm going to go ahead and add the object tracker like that. And so now then they can update that course. So, and then, yeah, does that answer the question? I know I'm running out of time here. Paul, is there other questions I should cover?
Nothing showing up at the moment, no.
A fun thing I could do is show you what the gradebook looks like if we have time. So when I go to my teacher dashboard, let me see if I can find one of these things that has actual submissions to it. I don't want to reveal those people's identities. Um, so if I go to the gradebook, so what you're going to see in the gradebook is that there's going to be student names, and then each activity, and then if there's a submission in the activity, then I can click that submission and go see what the code looks like. So if I can do, yeah. So here's a test one that I did. So I submitted this code as a student, and as a teacher, I can quickly run this code. So this is I call this night sky generator. It's this astronomy type activity. It's not done yet. You have to make the dots bigger or smaller based on the brightness. But I can see that the student hasn't finished it yet. And so I can look at the code. I can look at the questions, the reflection questions. Oh, they haven't answered any reflection questions. And I'll tell them, you know, keep working on it, and I'll submit the grade, and I'll go to the next one. So that's the miracle of the site, is just trying to keep track of all these submissions. If they submit it again, then I can see the new submission, and I can say, okay, that looks good, or not. And so it's trying to be as helpful as it can be. Yeah. So let me just sort of throw up the contact info at the end here. Oh, sorry, this is the wrong slides. But so if you want to send me an email here, I'm happy to.
Chris, I had posted your other email, your
Okay. That's fine.
where'd it
That'll
go?
work too.
Orban.14@osu.edu.
Yep. Yeah.
Okay.
And I think we're going to be back for coffee at some point, right? So so check out all the resources, and I'd love to chat more with people at the coffee.
Yeah, that was great. Thank you so much, guys. I just want to encourage you, especially if you're interested in learning more or need resources or want to talk about specifics of how to do this in your classroom, please sign up for our coffee hour, which is Thursday at 6 to 7 Eastern daylight time. And the link is also in the chat. And then you have Chris's email, which he so graciously shared. And I also want to thank you guys all for attending and working on all the things you're doing. We really appreciate all the physics teachers and everything you guys are doing. And of course, Dr. Orban, so thank you so much for giving this great talk. It's great. It's so helpful. If you have a few questions, we're happy to stick around just a few minutes here. Otherwise, thank you so much for attending, and look for more talks in the fall, but of course our coffee talk next week. Or this Thursday. This Thursday.
Yeah, thanks so much for having me. I can stick around for a few minutes too, so happy to do that.
Yeah, thanks guys. See lots of